Hello, my name is Jonathan Greiner with Basin Safety Consulting, Training, Service, and Supply. Today we're going over hydrogen sulfide awareness and respiratory safety. As you can tell by our picture here, our crew is in front of an air trailer, which is also known as respiratory safety trailer, SABA trailer, emergency rescue trailer, a lot of different names for it. Inside it has a plethora of equipment that we use for training as well as safe work on locations that have H2S. This is kind of our bread and butter. So first, we're going to get into respiratory safety. As a lot of you gentlemen know, and ladies out there, it is the primary component of a hydrogen sulfide awareness safety program is having people that are trained and capable in hydrogen sulfide work by means of a respirator. So in any hazard in our workplace, hazard elimination is always step number one. We want to make sure that efforts are taken to ensure that we are taking no more risk than necessary at any given time. So before we send someone into a hydrogen sulfide area where there may be, obviously releases of hydrogen sulfide, we have to ask ourselves, have we added or changed ventilation? Have we closed or blanked or pancaked anywhere where fugitive emissions may come out and impact somebody? Have we substituted materials or added chemicals in order to minimize H2S? And lastly, have we changed the way that we do our work or our manufacturing to prevent and exposure? And so that's kind of the beginning of the employer responsibilities is has the employer done everything physically possible to remove that hazard? And 9 times out of 10, we can find a little bit of fault there. So that's on us as employees as well to help our employers do that. So employers are required to provide respirators to employees when they're necessary, develop and make a program. And I know that everybody watching this has a program because we've helped create most of them. Identify and evaluate respirator hazards in the workplace, select to provide appropriate respirators, and lastly, provide training, which is what we're doing here today. That written respirator program needs to address some pretty high-level topics. I'm not going to go too deep into it, but obviously, how do we make sure we have the right respirator? Do they fit correctly? How do we verify proper fit of equipment per employee? Obviously, how to take care of the respirators, and as well as the H2S awareness, monitors, work practices, and making sure everybody's trained up and ready to go. So speaking of that, let's get into some of the hands-on respirator safety protocol. So types of respirators right out the gate. There are two main types. You're going to see atmosphere providing, which the gentleman on the left is wearing, or air purifying, which is the mask on the right. The atmosphere providing is obviously good in areas that are an IDLH. Well, that can be H2S. You can have diesel fumes. Any contaminant in the air that's chemical has an IDLH or an immediately dangerous to life and health threshold. Now, and it doesn't matter what the material is. If that's the case, an atmosphere providing respirator is going to be necessary. Now, and anytime you're working around H2S, you're going to need one of these as well. Now, anytime you're working around other contaminants, an air purifying respirator may work, and there's some specifics with the air purifying that you need to follow. And a lot of that has to do with NIOSH and can be found in the SDS of whatever chemical you're working around. So NIOSH is an international recognized body, but a local or a federal body that helps determine requirements and expectations for quality of equipment and when a piece of equipment will be necessary to work. So they work closely with OSHA, the CDC, the API, and a bunch of other groups to make sure equipment's certified and all the standards are represented equally. So as I mentioned, the IDLH atmosphere, immediately dangerous to life and health. That's when you're going to need a full face piece demand breathing air supply unit, otherwise known as just an SCBA or an airline. This picture here, you can see the gentleman with a 30-minute pack on, which is typically considered a work pack. And you also have 5-minute packs, which are designed for escape or quick escape. And we'll go over that a little bit here in a bit. So respirators, as far as the air purifying go, they have an assigned protection factor, basically a filter quality number that's assigned to them, as well as a filter code that's assigned to them based on the type of contaminant that you're around. Once again, I mentioned the SDS is the place to determine where and what type of respirator is needed. Medical evaluations. It's kind of a tie-on to the fit test to make sure that the respirator fits properly. Medical evaluation is done prior to even the fit test to make sure you are capable of wearing a respirator. Claustrophobia, even though it's not a medical condition, it can affect your ability to safely operate and wear a respirator. Any sort of ear damage, pulmonary function incapabilities, lung disease, etc., they're going to prevent your ability to wear a respirator. So these are going to be reviewed by a doctor typically, and they can be required yearly depending on your situation. But for most people, it's kind of a one and done, unless a medical emergency occurs, kind of thing. If you decide to wear a respirator voluntarily, perfectly okay. But the plan that we discussed earlier, the respiratory protection plan your company has, you have to follow that to the T, even if you're the only guy out there or gal out there with a respirator. Fit testing, as I mentioned, it's a component of respiratory safety. Make sure it fits correctly. You got two types. They're pictured here. You have a qualitative and a quantitative. Qualitative method is the picture on the top. Typically it's an irritant smoke. Hey, move left to right. Can you breathe? Do you breathe the smoke or an aerosol? Do you smell it? Typically we consider this the old school method. You have the new school method, the quantitative, where they're actually using a pulmonary function machine and giving you a digital readout of your pulmonary function. They need to be done at least annually, as well as more common if there's a change of the face shape, there's an issue with car accident, a lot of weight gain, weight loss, etc. Atmospheric hazards change, then a fit test may need to be repeated. During the fit test, as well as every time you wear a respirator, doing a seal check is absolutely necessary. You do a negative and a positive pressure test where you cover the inlet for your regulator. Breathe in, breathe out. In is a negative, out is a positive, and you make sure that there's no air. Typically, it'll make that almost like a passing gas sound out of the seal somewhere if there's any sort of breach. Obviously, the importance of maintaining seals may go without saying, but hey, just so you can't ever say I didn't say it, no facial hair. You can't have facial hair and wear this unless it's you want to do the Burt Reynolds look, which hey works for some guys. Obviously, long hair. Making sure you have the right face shape for the type of respirator that you're wearing. And then as you can see in the picture, any sort of eyewear that's necessary, you need to have these prescription lenses put in. You can't have the mask seal go over the earpiece of a pair of glasses. The respiratory program needs to be monitored by the company. Basically, hey, we started the day, this was the plan, it was working. Temperature or distance or whatever, weight distribution, whatever we're doing, it's not working, let's reassess. That's kind of on the employer as well as the employee to communicate when that may happen. If you need to wash your hands or your face, obviously you want to do that outside the work area. If you're messing with the mask at all, you don't want to be trying to clean it in the contaminated area. You want to leave and go to your decon zone or your green zone of the work area. Respirator cleaning. Not a bad idea to give it a swipe every time before you and after you use it. Some people, you're only required to clean it after use, but I'm like, oh, well, just in case. You can usually use a non-alcohol wipe or swab. If you really want to get a deep clean, you can always, put her in the sink with some Dawn dish soap. It dries pretty quickly. Wash it, rinse it, put it in the dishwasher drying rack, and you should be good to go. Don't put it in the dishwasher though. Just FYI. Respirator storage. You really should treat it like it's a life-saving device, as it is a life-saving device. As you can see here, the MSA bag is holding the respirator in its case. That's a Pelican case there that we use with the 5-minute pack on the side. You want to prevent damage, contamination, contact with moisture, chemicals, etc. Just being beat up. If it's floating around the back of a pickup truck, you're going to have a problem. And those respirators need to be inspected every day prior to use. Not every day if you're not using it. Then there's no reason to inspect a piece of equipment you're not about to use. Just daily before you go to use it, and then monthly as well. All right. So that kind of wraps up the respiratory protection program portion of this training. Now we're going to get into hydrogen sulfide awareness, or H2S safety. H2S safety is an important part of our industry. That's why it's an annual coverage. This does not meet ANSI 390. This is an older version, so if you need to have a 4-hour H2S course, such as H2S Clear, that is not currently offered online. You must go to an actual training center and get that done. Basin Safety is a training center for that. There are other companies around, so if you need that 4-hour, this is not ANSI approved. So exposure to hydrogen sulfide is one of the leading causes of death in the petroleum industry, hands down. You know, it is formed H2S when there's a decomposing organic material met with pressure and temperature, and there's a lot of places it can be present. So just kind of some open-ended questions here. You know, why do you think there's death from H2S? Like, where would you think it happens typically? If you were thinking around the tanks, inside the treater, next to a truck, you're absolutely correct. Potential locations, really every oil field location or place where tools are stored that have been around locations or had oil processed through them or work around oil, clothing, anything that's touched oil can have, or water that's been contaminated with H2S can have H2S on it. So really anywhere. And typically there is H2S. The question in everyone's minds needs to be how much H2S. So the reason we're going over this is obviously to prevent any of you from ending up like Ryan. Also, so you know how to take care of your personal monitor, understand how to clean it, make sure it's working properly, knowledgeable about how to apply basic first aid techniques if you are trained, understand emergency plans, and how to protect yourself on a daily basis out in the field. There are different types of respirators out there. We talked about the airline respirator, the air purifying, atmosphere providing. There are a couple of types. I'm not going to break into that. The SCBA kind of looks like a little scuba tank. Typically holds about 5 minutes of air. That's like an emergency pack. You get the heck out. Only going to usually run bigger guys about 3 minutes of air. So that's literally time to get down the stairs, cross location to the muster point. Not a whole lot else. There are 30-minute packs and even 45-minute packs, much bigger, typically of a lighter material than the steel 5-minute packs, and those are considered work packs or rescue packs. Standby personnel are personnel in a situation where operators are performing work around H2S. Their whole job is just to watch the guys, make sure no one goes down, and if they go down, they have instant rescue available. So that's another service that Basin Safety provides, for example. Responsibilities. Employees are responsible for being knowledgeable about this training, observing safe work, and informing your supervisor of anything you feel is not adequately addressed. So really, when it comes to H2S, the employees are really on the front end of, hey, is our program working? You know, because typically the managers and supervisors out there aren't out there masked up, gauging a tank or, you know, checking a truck or packing or, you know, ensuring that a float's working. They're not doing that. So if the tools, equipment, training that you've gotten doesn't seem adequate, you got to let them know so that they can give you what you need. So hydrogen sulfide goes by several different names. It's also called sour gas, rotten egg gas, has a rotten egg odor at very low concentrations, abbreviated H2S, more than 8 times as toxic as carbon monoxide, and nearly as toxic as hydrogen cyanide, which many of you know was used in World War II and afterwards for the gas chamber. So pretty deadly substance here. It is flammable. It has a LEL and a UEL, lower explosive and upper explosive limit, and a pretty wide range at that. So most gases, such as propane, methane, etc., are flammable from 4% to 14 or 15%. H2S is flammable from 4%, percentage mixed with oxygen in the air, and 46%. So a 400% increase in flammability than your typical natural gases. So extremely flammable. It does dissipate, however, very quickly in the atmosphere. So you'd need to have a very still, calm day with high levels of H2S for a flammable mixture to be experienced. And that's why a well site is kind of set up the way it is, you know, with large areas and distances, et cetera, but especially away from flammable or ignition areas. So some other characteristics of H2S, it's 1.18 vapor density. So that means it's about 18 or 20% is the number I typically like to use, heavier than air, meaning it'll settle in low-lying areas and kind of travel, make its own atmosphere. When it burns, it turns blue and releases another toxic gas, which is called SO2. And the reason they would make a more toxic gas is to remove the flammability out of it, especially when there's high levels of flammability because of that hazard. H2S is very corrosive, especially to harder metals such as steel. Softer metals such as nickel, etc., palladium, it doesn't affect as much. Gold, it's the harder steels. It creates hydrogen embrittlement, in which it changes the actual chemical structure of that steel to become iron sulfide, which is a pyrophoric and will ignite with enough oxygen mixed with it. So H2S, it's flammable, has more toxic, it's toxic, has toxic byproducts, as well as pyrophoric byproducts, depending on the type of steel that it's mixed with or has come into contact with. H2S exposure limits for the individual is 10 parts per million on an 8-hour day, 15 short-term exposure limit, and then 100 parts per million is where we hit that immediately dangerous to life and health threshold, IDLH. For SO2, it's about half that. So for a visual representation of how small of an amount that 1 part per million is, it's important for you to understand that really from a conceptual or a picture standpoint, it's the same as comparing 1 second to 11.5 days or 1 inch to 15.5 miles. So you're talking minute numbers when you're talking about 1 part per million or even 10 part per million. Heck, 1,000 parts per million, you're only at 1%. And that's fatal to anybody at 1,000 parts per million or 1% mixed in air. So when you think about a breath, especially if you're nearby where gas vapor is released, for there to be 1% H2S in there of that gas vapor, it's not a lot, candidly, first of all, out the gate. And then secondly, especially if you're nearby short bursts, you're trucking around tanks, etc., of air being released from a process, that's where your big hazards are going to be. You can also get into liquid, really any sort of liquid, water from the well, typical, salt water or oil. So that gets on your gloves or on your clothing, especially when it's cold and you get into a hot truck. Heat and vibration will bring the hydrogen sulfide out of the liquid, or the solution as they would say, and turn it into vapor or a gas phase. And when you breathe that in, that's when you're going to be in trouble. So it's formed by the decomposition of organic materials. As I mentioned before, really any sort of organic material. It's present in crude oil, water, natural gas, sludge, slurry, anything coming out of the ground. Acute health hazards, meaning immediate, are going to depend on the concentration of the gas, how long you're exposed to it, and your individual susceptibility, which makes it a little bit difficult to kind of break down. Most important, H2S can kill and will kill you if you inhale it at the right amount or right concentration. Now, once again, IDLH is 100. That's where people are going to start feeling a little bit woozy. Inhaling it's going to reduces the blood's capability of carrying oxygen, making your blood toxic, causes asphyxiation, making your lungs, incapable of working. It also affects the medulla oblongata, or the nervous center of the brain, which controls all movement and motor function, including breathing, running, and even the decision-making capacity, as well as paralyzing the sense of smell. So really, when you breathe it in, it kind of shuts you down. You basically become a little bit of a vegetable. On the skin, it's going to jaundice your skin, turn like a yellow as if you had an iron deficiency. And it can oxidize to form sulfuric acid as well, H2SO4, also known as battery acid, and burn your skin. So definitely don't want to get it on the skin and leave. Long-term or chronic effects of inhalation, easy dizziness, nausea, sickness to the stomach. I mean, you've poisoned yourself with hydrogen sulfide in a deep, long-term way. That's a bad situation to be in. Even if you survive, there's long-term effects. There's high-risk populations and individuals who really need to be concerned about H2S are people who have had eye or respiratory illnesses, who've consumed alcohol within 24 hours, individuals with psychiatric problems, and other variables such as body mass, physical condition, whether or not you're a smoker, your age, and your personal biochemistry. The effects of H2S exposures. H2S concentrations can vary from trace amounts to high amounts. The sense of smell can detect H2S as low as 0.1 parts per million. The odor threshold is only 0.1 to 1.5 parts per million. That means is when you're smelling it, if you smell that rotten egg odor, you're around very, 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 very low concentrations. 2 to 5 parts per million may cause nausea, tearing of the eyes, headaches, loss of sleep from prolonged exposure, etc. So the effects of H2S exposure from 20 to 100 part per million basically is fatigue, loss of appetite, digestive disturbances, conjunctivitis and respiratory tract irritation. Then you're going to start hitting some coughing. Your nose, your olfactory system is going to shut down. The throat's going to burn, etc. Then when you get from the 100 parts to 1,000 parts, then it kind of gradually steps up based on your system. And here's kind of a good rule of thumb. Basically, 1 to 500 is where people start to feel sick. 500 to 1,000 is where people start to lose oxygen to the brain and a loss of life is imminent. Then depending on how long you're around that 1 or 500 to 1,000 and your individual susceptibility is going to affect how quickly you expire. So if that happens, I've left this slide up here for a little while. You want an immediate action plan. You want to alert and account for employees. First of all, that's your muster point. The reason you have a sign-in sheet on locations with H2S, you want to know where guys are, and they should all be upwind or crosswind. And we'll talk about administrative controls in here a little bit, which that would be following your windsock and your all the way to the muster point area. Wear the proper breathing equipment if you have it available and have been trained. Alert people if necessary, and if you've been trained to rescue if it's necessary, then go ahead and perform rescue. But you should have a plan in place prior to working around high levels of H2S, not during and smack dab in the middle of an emergency. Typically a bad time to have a plan all over the place. Especially we're so kind of went over these. We're going to run 15 minutes with the eyes. It's like any physical contaminant. So I mentioned hydrogen abridgment. Rusty iron pipes. It can explode and ignite. It's pretty wild stuff. With customers or clients that have facilities with H2S are required to do facility surveys and determine whether or not they have levels of H2S. All right, so oil field workers, construction workers who work around H2S, electricians, etc. Personal monitoring is a requirement if a well site has the possibility of H2S, and we know every well site has H2S on it. It's just a matter of how much. So personal monitoring for H2S needs to be performed every day when they're working. That's why you have a single gas like this or a 4-gas, which we'll look at here in a little bit. Medical surveillance is a part of this as well. If you're consistently exposed to H2S, you want to make sure that you're testing your blood, testing your pulmonary function capability, etc. Engineering controls are, once again, part and parcel to the primary thing we're going to try to do, eliminate H2S. So there's weir systems where you're eliminating the amount of vapor and thus eliminating the likelihood of exposure through vaporization of liquid H2S coming out of the oil or the water. This is a weird system which can work with a drain on it, and obviously you have to be protected in certain areas, but the process itself would not be as hazardous. There's also vapor recovery units, once again, where they're pulling that vapor away, and there's chemical treatments as well that you asked. H2S scavengers are used where that actually pulls the sulfur away from the hydrogen, which is pretty cool. Air blowers, I mentioned that, and then also fencing facilities off to keep people away from certain areas, which give or take. It's an engineering or an administrative control, which is a method used to protect people from H2S, but does not actually physically protect you from an H2S exposure, such as a windsock. Hey, that's a tool, but if there's H2S around, the windsock isn't going to protect you from breathing it in. Am I right? Signage, same deal. Labels, warning signs, fences. Like I said, it's kind of a 50-50. First, the sign should look like this: danger, H2S poisonous gas. H2S may be present. H2S is present. Toxic, any sorts of these words like that would be acceptable for H2S safety. Respiratory protection, we talked about this a bit. This is what a cascade system looks like when put together. Multiple bottles all linked together, which have an output to an individual working to make sure that he can work safely around H2S. And I've be honest with you guys, I've painted a pretty ugly picture of H2S, However, I have multiple people. You saw the picture of the team there in the front. They work around H2S every single day as a part of their job. Their job is to, search and destroy, if you will, H2S. Make sure that the equipment works, make sure that the tests are accurate, etc. So there is a safe way to work around H2S if you have the right equipment and the right training. So one way that we determine those tests is the Tutwiler method, otherwise known as a gel silica system, where you have a tube like this, air is drawn through, and it tells you how much H2S is in that system. You can also protect your skin by any sort of water wicking, FR rated material will protect you from getting it on your skin. Rescue personnel have just basically, I'll make this one quick. They're going to use certain rescue equipment, but you have to be trained in rescue to rescue people. You don't want to, see the guy, walking around location like he's bored and make him the rescue guy because, hey, he's not doing anything else. Might as well put him in charge of something. Not acceptable. When it comes to rescue, the person needs to actually have the credentials. The same thing with detection equipment. People need to have detection equipment credentials before they're out there, rocking and rolling, detecting for H2S. And there's types of detection equipment. This is a 4-gas monitor. This one's detecting H2S, CO2, LELs, and of course oxygen and O2, just kind of determining what the levels are. This specific model, the Industrial Ventus MX4, you can put a pump onto, a separate attachable pump, and actually you detect H2S around corners with a wand inside of a tank, etc. They are different. You can't use a personal monitor to detect H2S inside of a process or a system. So routine use of them means you're going to be bump testing and sensor calibrating them, which detects, does it read H2S or the other gases, number one, and number two, when it does read them, does the alert equipment work? Does the klaxon, the siren go off, the beeping, all that? That's what you're going to be testing for. And typically they'll give you a date when you need to have that done by. Lastly, once again, kind of wrapping this up for everybody, putting the cookies on the bottom shelf, having an emergency plan, and people who are trained what to do before an H2S emergency happens is absolutely critical. That includes evacuation routes, areas of safe refuge, signals to alert personnel of an emergency condition. When a personal monitor goes off, it's designed to be loud enough for the individual to hear it and potentially somebody nearby. If you're across a location, especially in North Dakota or the Permian, when there's a lot of wind blowing, no one's going to hear that beep, beep. It's just you're not going to hear it. Same thing with yelling. You're going to yell and no one's going to hear you. So for that reason, having an air horn or some sort of visual, they almost like the YMCA kind of arm wave for the Y. If you do that 3 times or blast a horn 3 times, that's the kind of international signal for gas, or in this case, poisonous gas, H2S. So also reporting what to do after you determine there's an H2S emergency, and other emergency procedures. Who's in charge of rescue? Who's in charge to call 911? Who's in charge of driving the guy if the ambulance can't make it? It can't just be like, okay, guys, plan is H2S bad, safety good, work the play. It needs to be, it's kind of like watching the Giants play if you're running a plan like that. And that's not what we want. We want to, hey, you're the quarterback, you're the guy who calls 911, you're the guy who goes in for rescue, you're the person who drives, you're the person who alerts whoever, the management team, because one person can't do it all. And also, if you're sending guys out alone, you need to have that are working around H2S, you need to have some sort of check-in process with that individual, so that if he does go down, and this happens a lot where guys go down and they're not found for quite some time, people have to run the route well by well or site by site to find them. That's not, you don't want that. You want to have some sort of reporting procedure so people know where you're at. So once again, kind of wrapping this up, it's present in many of the areas in our industry. It's toxic, flammable, breakdown metal, and stuff. Becoming wind conscious when working around H2S activities, really anytime you're on a location, knowing always where the wind direction is extremely vital. As well as parking, so that you can drive away if there's an emergency. You don't want to be in a situation where your vehicle is downwind from a process that may be releasing H2S and you have no way of truly getting, to safety. So going crosswind or downwind, or excuse me, downwind, upwind from the H2S source is important. So knowing, where the area of refuge is and the muster point. Lastly, of course, making sure that you do not ever rely on your sense of smell for H2S. You can kind of smell it, once again, 1.5 parts per million, but on a daily basis, we need to make sure that we are relying on our detection equipment, and that our detection equipment is clean, properly bump tested and calibrated, and is working properly. All right, thank you very much for being a part of our training. Have a great day. You need to be knowledgeable, but candidly, there's not a lot you can do. Flushing of the eyes, if it gets in the eyes, any liquid in the eyes, and the lungs, try to break it up with either oxygen, if you have it on hand, or even breathing air can work, kind of clear it of the lungs so they're not continually pulling in those part per million level cellular hydrogen sulfide elements. And obviously, number one, have someone available to call 911. Number two, have a way to get everyone to the safe area. Number three, just wait for everyone to come and perform CPR if you're skilled and trained to do so. Ryan, who's a 25-year-old lease operator working in Dickinson, was exposed to H2S inside of a treater. There was a cloud released inside that treater that had H2S in it. He was overcome and lost consciousness. He was found relatively quickly. They pulled him out, but his monitor was not on him. So surprisingly, they found him quickly, put him in the truck, got him to the hospital, and a few days later, he passed away due to his injuries. Now, it is about one person a year up here that typically dies from H2S, and there are a lot of locations that have H2S on them. It's unfortunate. It's just a byproduct of our industry. Basin Safety does everything we can to mitigate, including using chemical solutions, but sadly, it does happen. And typically, it's because they weren't wearing the right equipment. They were standing downwind when they shouldn't.